Rule 1. Constant rule. When the user enters a constant value such as 3, the program checks that the input does not contain the variable x. Since the function is a constant, its derivative is 0. Therefore, the program outputs dy over dx equals 0. Rule 2. Linear function rule. When the input function is 2x, the program identifies it as a linear function in the form y equals cx. The derivative of a linear function is the coefficient of x. As a result, the program outputs dy over dx equals 2. Rule 3. Power rule. When the input is x squared, the program recognizes the power notation and applies the power rule. The exponent is multiplied by x and reduced by 1. This produces the derivative dy over dx equals 2x to the power of 1. Rule 4. Logarithmic rule. When the function lane x is entered, the program detects it as a logarithmic function. According to the logarithmic differentiation rule, the derivative of ln x is 1 over x, therefore. The output displayed is dy over dx equals 1 over x. Rule 5. Exponential rule. For the input e to the power of x, the program recognizes it as an exponential function. The derivative of e raised to x is the same function. Hence, the program outputs dy over dx equals e to the power of x. Rule 6. Sum rule using rule 2 internally. When the input function is 6x plus 3x, the program identifies it as the sum of two functions. Each term is differentiated separately. Since both terms are linear functions, the program internally applies rule to each term. The results are then combined, and the final output is dy over dx equals 6 plus 3. Rule 7. Difference rule using Rule 2 and Rule 3. For the input 8x minus x squared, the program detects a subtraction operation. The first term, 8x, is differentiated using Rule 2, while the second term, x squared, is differentiated using Rule 3. The derivatives are then combined by subtraction, resulting in dy over dx equals 8 minus 2x. Rule 8. Product rule. When the input is 9x multiplied by 3x, the program identifies it as a product of two functions. The program differentiates the first function and multiplies it with the second, then differentiates the second function and multiplies it with the first. The final output follows the product rule formula. Rule 9. Quotient rule. For the input to x divided by 4x, the program recognizes the division operation. The numerator and denominator are differentiated separately, and the quotient rule formula is applied. The program outputs the derivative without simplifying the expression. Rule 10. Chain rule. When the input function is 10x minus 9 cubed, the program identifies it as a composite function. It first differentiates the inner function, then multiplies it with the derivative of the outer function according to the chain rule.